Welcome to the deep dive. If you've spent any time on the water, you know the feeling. For years, for decades really, getting online far from shore meant one thing: VSAT.
Oh, yeah. The giant domes, the slow speed.
Exactly. The latency was just brutal. You'd measure data in megabytes, not gigabytes. But now, low Earth orbit satellites, LEOs, have completely changed the game, specifically Starlink Marine. We're now talking about streaming, real video calls, running a business hundreds of miles offshore.
It's a monumental shift, truly. I mean, network reliability has gone from being the sort of luxury item to the absolute backbone of everything on a vessel.
From crew welfare to navigation, guest experience, everything.
Right. And our mission today is to, cut through all the marketing noise and get practical. We're going to deep dive into the critical decisions captains and owners are facing, the hardware, the data plans, and most importantly, how to actually make it reliable out on the open ocean.
Okay, so a practical guide. We'll start with the gear, then we'll tackle the budget because those priority data costs are a big deal. And we'll finish up with the installation tricks you need to know so you don't drop that crucial call mid-charter. All right, let's start at the very foundation. The hardware. You've got yachts, commercial vessels. They're dealing with heavy weather, salt, heat, a lot of motion. So when you're putting a Starlink kit on a ship, which one is it? The older V2 dish or this new flat high-performance Gen 3? And why does it matter so much?
Okay, for any serious maritime use, professional or even high-end leisure, the choice is unequivocally the performance or flat high-performance Gen 3 kit.
No question.
No question. You might see some of those older V2 dishes floating around. Maybe someone repurposed one from their house. That is a mistake on the water.
I get that the Gen 3 is flatter, it has a lower profile, looks better, but is the performance really that different enough to justify the jump in price?
Absolutely. It's not just about aesthetics, it's about operational resilience. The Gen 3 is engineered for continuous duty, has much better thermal management.
Which means it can handle the heat in the tropics, for example.
Exactly. Places where older units might struggle or even fail. Plus, it's physically built for high-speed, in-motion use. It can take a washdown from a heavy wave.
So it handles the environment better. The heat, the vibration, the salt.
Yes, and it gives you a much more robust connection that holds on to the signal even when the vessel is rolling and pitching.
And what about that physical side? I keep hearing stories about connector failures on older units that are put on boats.
That is a key design difference. The Gen 3 was designed with marine mounting in mind.
Wedge mounts, flat mounts, that kind of thing.
Right. And crucially, the way the physical connector is oriented is designed specifically to reduce water ingress.
To stop water from getting in?
Exactly. Water and electricity are not friends in a marine environment. The Gen 3 is just engineered to minimize those failure points. For a professional, that resilience is non-negotiable.
Okay, so we're buying resilience with the Gen 3 hardware. But the real ongoing cost, that's the data. This is where the budgeting gets critical. Starlink Marine uses these special global priority plans. Can you give us a snapshot of what those data blocks look like and what they cost, say, in the US market?
So global priority is the tier designed for exactly this.
Right.
Ocean and global travel. It gives you that top-tier access pretty much anywhere. In the US, you're typically looking at 4 main data blocks.
Okay.
There's a 50 gigabyte, a 500 gigabyte, a 1 terabyte, and a 2 terabyte plan.
That is a massive jump in data allowance. I'm guessing the price jumps right along with it.
It certainly does. Based on current pricing, that entry-level 50 gig plan starts around $250 a month.
Okay, that's the starting point.
But it scales up quickly. The top-end 2 terabyte plan, that'll run you about $2,150 a month.
Wow.
And while it sounds like a lot, you have to remember what it's replacing. VSAT contracts were often charging $10, even $20 per gigabyte.
Right, for far less bandwidth.
So the cost per gigabyte is way down, but the absolute monthly bill is still a significant line item.
That's a huge investment. So how does a captain budget for that? Usage can be so unpredictable. A few weeks with just crew, then one charter where everyone is streaming 4K.
Best advice here is to start conservative. Maybe go with a 500 gigabyte tier. And then you have to monitor usage just relentlessly for a few weeks. You need real data to right-size your plan.
But what's the golden rule?
The golden rule is always to use cheaper networks when you can. When you're near shore, say within 50 miles of land, offload as much traffic as you can to LTE or 5G. That saves your expensive priority data for when you're actually out in the middle of the ocean.
That's a smart strategy. Okay, but let's face it, things happen. Someone starts a huge download and torches that 500 gig block in 2 days. What actually happens when a vessel runs out of that priority data mid-charter?
That is the moment of truth. And what happens depends entirely on how the plan is set up, specifically if the user has opted into overages. There are two scenarios.
Okay, walk us through them. What are the consequences?
Scenario one is you've opted out of buying extra data. In that case, the system switches to a free, unlimited data mode.
Free and unlimited sounds good.
It does, but the speeds are dramatically throttled. We're talking down to 1 megabit per second down and half a megabit up.
So basically enough for an email or a text message, but that's it.
Exactly. Streaming is dead. Video calls are dead. You have basic communication, but zero luxury bandwidth for the rest of the month.
And what's scenario two if they've opted in?
If you've opted in for automatic overages, the system keeps the high speed going. The fees can vary a bit, but for some plans, it's around $2 per gigabyte. For others, it'll just top you up automatically in 50 gigabyte chunks for about $25 each time.
So you keep your speed, but you could run up a massive bill if you're not careful.
The operational advantage is clear, but so is the financial risk.
So the defense has to be monitored.
Precisely. You cannot afford to be surprised. The simple vital tip here is to configure alerts. Set them up in the Starlink portal, and even better, in your onboard router to warn you when you've used, say, 75 or 80% of your data block.
Got it.
And one last crucial point on data. It does not roll over. You use it or lose it each month. All right, moving on from cost, we have to talk about physics. You can buy the best plan, the best hardware, but your performance hinges entirely on the physical installation. Starlink needs a clear view of the sky.
That makes perfect sense. You mentioned the Gen 3 uses a wedge mount. What is that, and what are the absolute non-negotiable rules for installing it?
The wedge mount is one of the standard options. It's a rigid base, and it has about an 8-degree tilt built right into it.
And that's to help shed water.
To shed water, and also to improve its view of the sky when the boat is rolling. But the most important stat is orientation, the direction you point it.
So how should it be tilted?
You have to tilt the low end of the wedge toward the clearest patch of sky. The direction with the fewest obstructions. Antennas, rigging, that sort of thing.
Okay.
But for vessels moving at speed, a lot of professional installers will orient the low end forward.
Forward. Why is that?
Because when a boat gets up on plane, the bow rises. Tilting the dish forward helps counteract that angle, improving its view of the sky ahead of the boat, which is usually where the view is clearest.
So it's a strategic choice based on how the vessel actually operates.
Absolutely. Yeah. And you cannot overlook the connectors. Always keep them pointing down or sideways, never up.
To prevent water from pooling in them.
You got it. That leads to corrosion and eventually failure. It's such a common problem.
So what are the biggest mistakes you see people make? Things that seem okay on day one but cause a total failure a month later?
The sources all point to three main issues: wrong orientation, bad cable runs, and mount flex.
We covered orientation. What about the cable runs?
It's all about protecting the signal and the hardware. You have to route the main cable with drip loops so water runs away from your interior connections.
Makes sense.
Use proper strain relief. And critically, keep that Starlink cable far away from your radar and other high-power lines. EMI, or electromagnetic interference, can really mess with the signal.
And mount flex is just what it sounds like. The mount itself is moving.
Exactly. If the surface it's mounted on vibrates or flexes too much, the antenna is constantly trying to realign with the satellites. That causes dropouts and slower speeds. And of course, just maintain that unobstructed view. Don't let it get shadowed by the boat's own superstructure.
Okay, so we've established that the speeds you can get at sea are now incredible. You can have multiple people streaming. But amazing speed isn't the same as constant reliability, especially for something critical, like a video call with a client. How do you make that connection bulletproof?
The answer is redundancy. The solution is what we call a hybrid network design. You achieve true reliability by bonding or blending Starlink with an LTE or 5G connection through a specialized router.
So you're creating a multi-layered system that's constantly shifting traffic around. What's the main benefit of doing that?
The benefit is you eliminate almost all user-visible drops. The intelligent router handles it all seamlessly. It can be set to prioritize the cheaper, low-latency 5G when you're near shore.
Right.
And then, as that signal weakens, it automatically falls back to Starlink when you head offshore. It smooths out all those little micro drops that would normally kill a video call.
That seems absolutely critical for operations. But now you have all this bandwidth. On a busy charter yacht, how do you stop a guest streaming a 4K movie from hogging the connection that the captain needs for weather data?
That requires smart traffic management. Use tools like quality of service or QoS and VLANs, which are virtual local area networks. You have to use these to prioritize the important traffic navigation, operations, voice calls over guest entertainment.
For those of us who aren't network engineers, what does that actually look like?
Think of it like a highway. QoS puts your critical traffic, like the captain's weather data, in a dedicated express lane. Your VLANs separate the networks, one for crew and operations, another for guests.
I see.
Then you can actually cap the guest Wi-Fi, the slow lane, at say 10 or 25 megabits per device. The guests can still watch their movie, but the second the bridge needs to download an urgent file, the network guarantees that critical traffic gets through without any delay.
That is the definition of smart management, especially when the data itself is so expensive. Speaking of moving around, you mentioned the Global Priority Plan is designed for mobility, so a vessel can really move between, say, the US, the Caribbean, and Europe without issues.
Yes, that is the entire value proposition of the Global Priority Tier. It is engineered specifically for ocean and global land use with full in-motion support. You're paying for that seamless international mobility. It's a massive leap from the old days.
This has been a really critical deep dive. Let's do a quick recap. The 4 key takeaways for someone facing this decision right now.
Okay, I'll start. Number 1, the foundation. Gen 3 performance hardware is the only real choice. It's the durable, marine-ready kit you need for reliable operation.
Second, those expensive global priority plans, they require careful management. You have to pick the right data block, monitor it constantly, and use cheaper LTE near shore to save that precious satellite data.
Third, installation matters. A lot. Use the wedge mount, tilt it correctly, low end toward the clear sky or forward, and keep those connectors pointed down to prevent corrosion. It's non-negotiable for stability.
And finally, real reliability comes from a hybrid network. You have to bond Starlink with LTE or 5G through a smart router to guarantee that seamless failover for critical applications like video calls.
Right. And with high-speed Starlink now serving as the fundamental backbone for, well, everything on a vessel, the problem has shifted. It's no longer just about buying the hardware and paying the bill. And this raises a really important question for every captain and owner out there. If this connection is now mission critical, what policies and infrastructure do you need to implement and enforce to guarantee that a guest streaming a movie never, ever compromises the safety or navigational ability of your vessel? The connectivity problem is solved. The management problem is